So this is a video where we'll look at part A of problem number 2 from the 2013 AB exam. And this is definitely a calculator problem, and the situation that they present is that a particle is moving along a straight line, and for the interval from 0 to 5 the velocity of the particle is given by this pretty ugly looking function, and the position of the particle is given by some unspecified function s of t. We are told that at t equals 0 the position s is 10 units from a fixed point. Find all values t on the interval 2 to 4 for which the speed of the particle is 2. So first thing that we need to kind of recall to answer this is that when motion is happening in one dimension, back and forth on a line or up and down on a line, speed can be defined to be the absolute value of velocity. Now if the motion's happening in more than one dimension, you have to kind of change this a little bit, but in a lot of these questions the motion is always on a straight line, and so we can define speed to be the absolute value of velocity. And so really what we would need to know here is we would need to know where on the interval from 2 to 4 does the velocity function equal plus or minus 2. Since speed is the absolute value of velocity, we're looking for a speed of 2. The absolute value of 2 or negative 2 would give us 2 for our speed, and so we would need to determine where these things happen. And I have the function, the velocity function, already graphed on the calculator here, so we'll just bring that up on the screen. So I graphed this, and I think right now my viewing window goes from 0 to 5 on the x-axis or the t-axis. I'm going to shrink that down a little bit more, and I'm going to change it from 2 to 4. So I'm going to show the piece of the graph that we need to be concerned with here for part A. It has to go from 2 to 4. And if we look at this graph, we would want to know where on this graph the velocity value is 2 and where on this graph the velocity value is negative 2, because those are the places where our speed is going to be 2. So what I'm actually going to do is I'm going to graph two more things. I'm going to graph y equals 2. I'm going to graph y equals negative 2. And so what this shows is that there's a point right here where the velocity of the object is positive 2, and therefore the speed is also 2. And then there's a point right here where the velocity of the object is negative 2, and therefore the speed of the object is positive 2. So I'm going to have to use the calculator to figure out what this t value or x value is, and then also what this t value or x value is. And so I'm going to use the intersect feature, so you guys have probably used this a handful of times. I'll find that one up here first. So these are the curves that are crossing. I'll give the calculator my guess, and we get a t value of approximately 3.12, and I can truncate that. I could write 3.127, or I can round it up. We do want to carry 3 digits of accuracy beyond the decimal, so I'm looking at 3.128 as the first time where the speed of the object is 2 on the interval from 2 to 4, and then we have to do this one more time to find that second value we were mentioning a few seconds ago. And so let's see, my first curve, let's see, so I am on the velocity curve right now. Just wanted to double check that. So I'm on the velocity curve. Now I've already found where the velocity curve intersects that, so I'm going to have to jump down to my y equals negative 2 line. So now I'm definitely on that. Give the calculator our guess, and we'll be able to rattle off our second answer. So our second value, where the speed of the object is positive 2, is approximately 3.473.